Have you ever wondered if it would be possible to destroy a black hole? It sounds absurd, right? After all, they are considered the universe's unbeatable monsters, devouring everything around them without a trace. But what if I told you that there are theories, some as bold as they are terrifying, that propose ways to take down these cosmic entities? Yes, we're talking about nuking them, colliding black holes, and even manipulating exotic matter. It may sound like science fiction, but these ideas are rooted in real concepts from astronomy and physics. And the most curious part? One of these options might actually be possible. But which one? And more importantly, what are the risks? If you want to discover how this space mystery could be unraveled and what might happen if we tried to destroy a black hole, stick around until the end of this video. I promise you'll be surprised by the space facts I'm about to reveal. You won't want to miss this. Nuke it. Imagine this: what if the solution to destroying a black hole was at the tip of a nuclear missile? The idea, though intriguing, faces many challenges. A black hole is a region of space where gravity is so intense that nothing, not even light, can escape. The energy released by a nuclear explosion may seem powerful, but in reality, it would be like trying to put out a fire with a bucket of water. Nuclear explosions are colossal on Earth but insignificant against the relentless forces of the universe. Even if we tried to fire an absurd number of nuclear bombs, we'd be dealing with something that has already swallowed entire stars. The space around a black hole distorts physics as we know it. So launching a bomb, or several, would simply disappear into the abyss without making any difference. The gravitational field of a black hole, especially near the event horizon, deflects any attempt at attack, making this method one of the least practical ideas in space exploration. The very nature of black holes challenges this approach. Even if we managed to detonate a bomb inside it, the result would only add more mass and energy to the gravitational monster. Far from destroying it, we'd actually be feeding it. It's fascinating to think about how something so devastating on Earth becomes irrelevant in space. And this is just the beginning of the many space mysteries surrounding the nature of these colossal objects. Antimatter. What if, instead of bombs, we used antimatter? We know that when matter and antimatter meet, they annihilate each other completely, releasing immense amounts of energy. However, throwing antimatter into a black hole would be less explosive than we might expect. What many don't realize is that once antimatter crosses the event horizon, it is subject to the same gravitational laws as regular matter. Upon crossing this point of no return, the antimatter would be absorbed and added to the black hole's mass without causing the annihilation we see in other contexts. After all, inside a black hole, the laws of physics as we know them cease to make sense. There is no explosion, no annihilation. The antimatter would simply merge into the hole, feeding the insatiable appetite of the singularity. So, even if we had an infinite amount of antimatter, we would just be feeding the black hole. As interesting as the idea of using such a powerful substance to destroy this giant of the universe may seem, the result would be the opposite of what we want. Once again, the universe shows us that our traditional methods of destruction simply don't work in the realm of space exploration. Anti-black hole. The idea of an anti-black hole is intriguing. If antimatter has its counterpart in regular matter, could there be something that is the opposite of a black hole? Something that repels all matter instead of attracting it? In theory, the concept makes sense. An anti-black hole could undo what a black hole does, reversing the process of compression and absorption. However, in practice, this raises more questions than answers. An anti-black hole would need to obey physical laws opposite to those that govern the universe as we know it. It might be a form of exotic matter or energy. But even if such an entity existed, colliding it with a black hole would be a monumental task. The encounter between the two might result in mutual annihilation, but it could also create a new form of chaos in space. These exotic concepts show just how much we still have to learn about the universe. The very idea of anti-black holes makes us reflect on how far our understanding of astronomy is from being complete. Science continues to search for answers, and it's possible that one day, a new theory will emerge, changing our perspective on the mysteries of space. Destroy the event horizon. The event horizon is the point of no return of a black hole. It's the final boundary where anything that crosses it is doomed to be consumed. Now, an intriguing idea emerges. What if we could overload the black hole with so much energy that the event horizon itself would be destroyed? This could, in theory, deactivate the black hole and release what's trapped inside. The problem is that the event horizon isn't a physical barrier but a mathematical boundary. we can't destroy it the same way we destroy a wall. Furthermore, by trying to overload a black hole, we'd only be adding more mass and energy, making it even more powerful. Gravity would increase, and the event horizon would expand, making the destruction of this point of no return an impossible task. Even with attempts to manipulate this cosmic structure, we're dealing with forces beyond our ability to control. The event horizon remains an enigma, a point of reflection on what we really know about the universe and its structure. The idea of destroying it seems fascinating, but so far, there is no known way to achieve it. Overfeeding. The concept of overfeeding a black hole might seem contradictory, but some scientists have considered the idea. What if we dumped so much mass and energy into a black hole that it could no longer sustain itself? In theory, a black hole could reach a point where its mass and charge become so great that it collapses in a different way. However, in practice, this might not have the desired effect. The more mass and energy are added, the bigger and more powerful the black hole becomes. Unlike a living being that could explode from overeating, a black hole just grows. Additionally, increasing the charge inside it might create new forms of instability, but these wouldn't necessarily destroy it. It would simply become denser and more massive, making any attempt to eliminate it even more difficult. Even so, this approach raises an interesting question about the limits of physics and astronomy. We are constantly learning more about how these cosmic giants function, but it seems that overfeeding them wouldn't offer a real solution. Once again, the mystery of space teaches us humility. Breaking physics. The attempt to destroy a black hole could lead us to question the very laws of physics. If we could destroy the event horizon, we would be tampering with the foundations of relativity and gravity. This would mean that objects could escape from inside the black hole, something that, as far as we know, is impossible. It would be like breaking the very fabric of space-time. By violating these laws, the universe as we know it could be altered in unpredictable ways. Modern physics tells us that nothing can escape a black hole, not even light. So, destroying a black hole is not only a technological or energetic challenge but also a philosophical dilemma. What would happen to the laws that govern the universe if a black hole were undone? The consequences could be catastrophic. This perspective makes us reflect on how much there is still to discover in space exploration. Each step forward in the study of black holes brings us closer to answers, but also reveals how fragile our theories may be. Breaking physics, however, might be the price we would pay for attempting something so bold. The safe option. The safest way to destroy a black hole is to wait for evaporation via Hawking radiation. If all these methods seem too complex and risky, there is a safer option: waiting. According to Stephen Hawking, black holes are not eternal. They slowly lose energy through a phenomenon known as Hawking radiation. Over time, billions or even trillions of years, a black hole could simply evaporate until it completely disappears. This idea offers a much more peaceful solution than trying to blow it up or overload it. However, the timescale involved is enormous, meaning that for all practical purposes, the black hole will remain there for a very long time. Hawking radiation, however, gives us an interesting insight. Even black holes, which seem unbeatable, have an end. This perspective shows us that the universe operates on timescales that are almost unimaginable for us. Hawking radiation reveals that despite their eternal appearance, even black holes follow the fundamental laws of thermodynamics. However, waiting billions of years to see a black hole disappear may not be the most practical solution, but it is the only one that respects the laws of physics as we know them. Although we cannot control or accelerate this process, it reminds us that the universe is constantly changing, and what seems invincible today may not exist tomorrow. Colliding black holes. Now, let's explore what happens when two black holes collide. This cosmic event is one of the most violent and energetic occurrences in the universe. When two black holes get close, they start orbiting each other, speeding up until they finally merge into one. This process releases gravitational waves, which are ripples in the fabric of space-time, detectable from billions of light-years away. The merger of two black holes creates an even bigger and more powerful black hole. If the goal were to destroy a black hole, colliding two of them wouldn't solve the problem, it would only create a more massive gravitational monster. Rather than eliminating them, we would be making them stronger. This merger is a spectacular event, and thanks to advancements like LIGO, we can detect these gravitational waves and study black hole collisions in greater detail. However, this phenomenon also gives us a glimpse into the limits of space exploration. Not only are these collisions uncontrollable, but they are also completely beyond our technological reach. watching black holes collide reminds us of how small we are in the grand scheme of the universe. At the same time, these kinds of events provide us with a unique opportunity to learn more about the behavior of these cosmic giants. Exotic matter. Finally, let's dive into the most exotic idea, exotic matter. This is a theoretical form of matter that would have properties completely opposite to regular matter. It's believed that exotic matter could have negative energy or violate the laws of physics as we know them. If we could manipulate this substance, perhaps we could destabilize a black hole from the inside out, fundamentally altering its structure. Exotic matter is still a hypothetical concept, but in theory, it could weaken the gravitational field of a black hole, preventing it from continuing to consume matter. Imagine using it as a sort of gravitational bomb that would neutralize the forces that make a black hole so dangerous. Of course, all of this is still in the realm of speculation, and we don't have solid evidence that such matter exists or how it would work in the context of space exploration. However, this concept makes us think about how the universe may hold secrets beyond our current understanding. The use of exotic matter to destroy a black hole is one of the boldest and most out-of-the-box ideas, but it reminds us that in astronomy, today's impossibility could be tomorrow's scientific fact. As our understanding of space and physics advances, we may discover unimaginable ways to deal with these cosmic giants. So, now that we've explored various wild, and some even plausible, ways to destroy a black hole, the big question is, will we ever succeed? Or will these gigantic cosmic monsters continue to reign supreme in the universe? For now, it's up to us to observe, study, and question. And who knows, in the future, science may bring us even more surprising answers. Now, I want to hear from you. Which of these ideas for destroying a black hole did you find the most intriguing? Is there another theory you'd like to see explored? If you enjoyed these space facts and want to keep uncovering the mysteries of the universe, make sure to subscribe to the channel and turn on notifications. There's much more space exploration to come, and I don't want you to miss a thing. See you in the next video.